We already know that we can use the law of sines if we have an oblique triangle, meaning a non-right triangle. If we have a known angle and its opposite side length, and then one more piece of information. So the triangles that we could use would be our side angle, our angle side angle, where the side's included between the two angles, and then side angle, which would then result in possibly the ambiguous case where you could have one triangle, two triangles, or no triangles. But the question that remains is like, what if we don't have an angle on its opposite side? So there's two scenarios that could happen, which is side angle side, where the angle is included between the two known sides, or we don't know any of the angles, but we know all three side lengths. So we have to come up with a new approach. And this new approach is our law of cosines. So we have law of sines and we have law of cosines. So what is the law of cosines? So in words, the law of cosines is the square of one side of a triangle equals the sum of the squares of the other two sides minus twice the product times the cosine of their included angles. That's a lot of words there. So let's look at the formulas for it. So the top formula here is the equation that comes from the law of cosines there. So the square of one side of the triangle. So we're going to be looking for one side of the triangle. We know this angle. So when we use this top equation, it's because we know what this angle here is. So that's angle C. We know that. So I'll just write it now. We will also know the two sides that include that angle. So we'll know this side, we'll know A, and we'll know side B. And we're going to be looking for side C minus 2 times the product of A and B times the cosine of C. So the angle opposite the missing side. Okay. So again, just going through it. This is the side we're looking for. This is always the angle opposite that side. You will need to know that angle measurement. And then these two are the other two sides. Now I want to stress this because this is c squared, but it could be a squared equals c squared plus b squared. It could be a squared equals c squared plus b squared. So like understand the structure of it and what each of these terms represent. Now, the second equation here is the law of cosines, but we solved for the cosine C, and this will be used when you have side. So you have all three sides here. And this top one we use when we have side, angle, side. So that's when we use that one. So again, once we have the triangle, we recognize that we either have side, angle, side, or we have side, side. And then from that, we're going to be able to use our law of cosines to solve. Now, just like we talked about with law of sines, when does this work? You're going to be given two sides of the triangle and the included angle. Again, that's your SAS triangle. The other time you would use this is you are given the lengths of all three sides. That is the SSS triangle. So that's when we use law of cosines. Tips for using law of cosines. Here are some. So again, understand the structure of the equation. What I mean by that again is like you may be looking for side B. So if you're looking for side B, then the two other sides would be your A and your C. So, and then the angle here would be angle B. So understand the structure of that. When you are solving for the angle, so SSS, always find the largest angle first, because what will happen is you will use law of cosines to start the problem, but then you will most likely go to law of sines. If you don't find the largest angle first, you may run into a contradiction with law of sines. So how do we avoid that? Always start with the largest angle first. How do you know which one's the largest? It's going to be opposite the first angle. Sorry, it's going to be opposite the largest side. And lastly, type everything in one line in the calculator. Don't do individual calculations. You're more likely to make a mistake. One last thing that I didn't add here is when you find the angle, you will always get one angle. We do not have the ambiguous case. Let me just add that here. No ambiguous case when it comes with the law of cosines. So again, there's no ambiguous case when it comes to the law of cosines. And so that's the law of cosines. And now we're going to look at some examples with that.